Welcome all to this special panel discussion on Victoria's manufacturing post-COVID future. My name is Professor Alan Duffy, Director of the Space Technology and Industry Institute at Swinburne and Lead Scientist of the Royal Institution of Australia. Before we begin, I'd like to acknowledge the traditional custodians of the land on which my institute and I am joining you, the Wurundjeri people of the Kulin Nation. I want to pay my respects to the elders past, present and emerging, and extend those respects to all Aboriginal and Torres Strait Islander peoples who may be joining us. Now in this session, we're going to hear from our two guests. I'll direct some questions to them, and then you in the audience will have your chance to ask questions as well. So please do, throughout this period, get thinking and make sure you jot down the questions that come to mind. You will get your chance. Now, our two guests could hardly be more qualified to speak about Victorian manufacturing. We're joined by Mr. Jeff Lang, the Executive Director and Chief Technology Officer of Titomic Limited, a senior executive and director with over 30 years experience in creating advanced materials and manufacturing technologies across multiple industry sectors, for which he's received more than just a few international awards. Jeff has led efforts in the development of future advanced technologies, 3D printing, green manufacturing, and Industry 4.0 systems by driving a culture of outside-the-box creative thinking. He assists companies, organizations, and governments with creative solution resolution by analysis of the conceptual ideas and products to effectively transfer new technologies through to realization. We also have Dr. Steve Dowey, the Technology Manager at Sutton Tools, an industry fellow and senior lecturer at RMIT University, and the founder of the Smart Enough Factory. After serving in the Royal Air Force, he gained a PE-Eng and PhD from Hull University and worked with SCADA, PVD coating, and associate equipment development for cutting tool and semiconductor applications. Steve's implemented a low-cost, low-code Industry 4.0 framework at Sutton Tools, and by working with the Australian Defence Materials Technology Centre and partners, has created the Factory in a Box. This is Steve's Industry 4.0 focus is on the Smart Enough Factory, where issues of cost, security, and STEM skills are addressed to ensure the benefits of Industry 4.0 can reach the Australian SME. That is, to quote the man, low cost, low code, and low risk digitalisation. Yes, I'd like to throw it over to you just to say a few words about the topic, about your work and the company.
Okay, look, Titomic's an interesting company that probably represents how research can get commercialized. It originally started Titomic on the concept of a direct manufacturing centre with the CSRO. The government would have wanted to look at how we could develop our mineral deposits and build more value chain around that. So predominantly around titanium. We have huge amounts of titanium mineral sands, but we weren't doing anything more than selling it as titanium dioxide for pigments. So it was an opportunity to look at developing the metal phase of that, and we thought it was good to align that with some of the next generation manufacturing, such as 3D printing. So I started that project back in about 2008 with the CSRO. It took about 6 years of research and that, and then basically in 2017, we had quite a novel patent on a new process where we got an old technology, which was a coating technology called cold spray. We saw the advantages of that being for 3D printing, a lot faster, no size restrictions. And so we developed that into a business proposition. And then we listed that company on the Australian Stock Exchange September 2017. Nothing more than a patent in our hand, but it's been an interesting journey ever since. So we've been able to build Titomic from the ground up, develop new equipment, and probably more importantly, just really build close relationships between industry primes overseas in defence and aerospace, but also with the research sector in Australia too. So Titomic moves forward. We're really about pushing advanced technology using digital threads such as Industry 4.0, modernising the equipment, but not forgetting the fact that we're very strongly linked to traditional manufacturing as well. So I think a key bit moving forward out of COVID is really understanding those differences and not about just getting rid of what was old, that's there and it's benchmarked for a reason because it actually works. It's really just how we use advanced technology to complement what's already there traditionally and how we improve process and also the greening of manufacturing as well. Sometimes we can't avoid the situation that metal manufacturing is a quite dirty and toxic industry. So we need to improve that area as well as we face some of these climate crisis situations that are coming our way further and further. So Titomic's really focused on doing that liaising with traditional industry, introducing advanced technology, and probably really looking and defining sustainable resource management and manufacturing as well. So that's a bit of a snapshot of what Titomic does. Yeah.
Awesome. Just to our audience, I told you we had the perfect guest here. Steve, let's hear from you and your company's work.
Thank you, Alan, and thanks, Jeff. That's a great introduction to Titomic and your thinking. Look, I'll go backwards a little bit in the sense that I think Alan, the last thing Alan finished with, there was something that I'm looking at with a smart enough factory, and that's this concept of low code, low risk, and low skill. And the presentations I often do on that, I often sort of phrase that says, look, it's a bit like nailing jelly to the wall. You know, it's actually impossible, all those things. So what you have to do is you have to change your jelly. So this is going to be maybe we'll get to that in the discussion about changing your jelly. So keep that in mind.
I'll that question.
I'll talk to you a little bit about Sutton Tools, because I've got many hats, I guess, but Sutton Tools and this is a really interesting one, because the topic of advanced manufacturing, Sutton Tools is a traditional cutting tool manufacturer established in 1917, in the throes of the First World War. Two brothers came over from the UK, Sutton Tool and Gage. They are very much what you would class as something that was very, very sort of industry one almost, essentially, looking at the supplying the traditional manufacturing. But Sutton's has survived, partly maybe through the 60s, through some of the tariff restrictions actually in Australia, and sort of sneaked on the radar there. But we're now a world-class sort of cutting tool manufacturer. We're still able to be there and still operate in Australia. But we do that through export, and we do that through in automation and what have you, but we also ensure that we've had a long association with research and development, and we've always maintained that sort of overseas view of seeing what's going on around the world, and I think that's paid us paid us dividends as we're going along. So I'm sure we'll talk about Sutton Tools later on in advanced manufacturing, but RMIT, I actually lecture for on design for assembly and automation, and those sort of subjects come in really, really handy in the sense of what we're doing with our processes. Because maybe I'll touch back on that, is that Sutton's been a traditional manufacturer. The product has all the technology in it. When you buy the end mill, you see the surface finish, you see the edge finishing, you see the PVD coatings on there, but the know-how of the processes and those sort of structures within the company are what that's a secret sauce, essentially. And so that's something that's really interesting to think. And again, the Smart Enough Factory, that's with the DMTC activity, where we span out the Factory in the Box project from there. And that's this concept of smart enough. And so it's that good enough is good enough phrase. And I think that's something that is really important to bear in mind, that Industry 4 is actually forecast to be here in 2030. It's something to look to the future to. And in some respects, it means that people think that we can't do much now, but there's a heck of a lot you can do now. And that transparency of process is really what we're trying to sort of help to do. We're not necessarily looking at that sort of full automation or that complete horizontal and vertical integration of value chains, as all you people who are into Industry 4 definitions I'll talk about. But there's a heck of a lot you can do right now that to involve to improve your productivity. That's at relatively low cost.
All right, look, we'll certainly touch on more about Industry 4.0. I might ask Jeff, though, just to set the initial scene, big picture. What does modern manufacturing look like today?
I suppose modern manufacturing for us moving forward is about probably moving away from, let's call it, I proposition it as like cheap labour zones of controlled manufacturing for a long time. We lost a lot of Australian production capability in manufacturing over to Asia, cheap labour zone. But modern manufacturing moves away from cheap labour and focuses more on productivity out of equipment and skills as well. So I suppose it's very important we understand the requirements of industry from both a STEM level and also from a TAFE level as well, but really just how we work cohesively within that network, right? So the current value proposition for a manufacturer is like, how do you form a unique value proposition? And really, it's been very much cost driven for so long in manufacturing, and where China's been able to dominate that market. And I think Australia, we lost a lot of that capability because I think the end consumer were looking for a cheaper type of product. But I think that's shifted greatly. So I think modern manufacturing is more representative of a larger picture. It's not just about producing a product, producing a widget as cheap as you can. It's about getting maximum performance out of that product and also looking at the whole life cycle of that product too. You know, what is the whole value chain? We know with the younger generation, they're starting to now look at product and really define a company, you know, so they'll look at what's the company's carbon footprint, for instance? What are the ethics of the board of that company and so forth? So we're really moving into a new territory, and we can't now just hide behind one little sector. I think with the age of the digital era and digital ecosystem, everyone has a lot more access to information nowadays. So when we consider modern manufacturing, it's now moving away from just having a factory pumping out a little widget. It's really about that cohesive approach, understanding the whole value chain as a manufacturer. Where you supply your feedstock coming from, you know, what's the security of that feedstock, then moving all the way into the life cycle of a product to cost of manufacturing, improvements in the manufacturing. So it's quite a big area, and I tend to now look at it, I call it that manufacturing ecosystem. So if there's one area to really explain what modern manufacturing is, I would call it a manufacturing ecosystem, really understanding the end-to-end value chain of what that actually is. And like anything, you can get into the complexity, go right down the rabbit warren and get absolutely lost in that area. But I think that's why we need to sort of condense it down, have a narrower bandwidth. And I suppose looking at a manufacturing ecosystem is really that's what that value chain is. So modern manufacturing to me is relative to that, let's call it that manufacturing ecosystem.
Just on that point then, how important is supply chain risk, sovereign capability as a part of that ecosystem? You don't necessarily need the entire ecosystem to be onshore, right?
No, you don't, but we need to have security. So one thing that we've seen with COVID, and probably the one thing that's affected manufacturing in Australia more than anyone else and globally, is the disruption to supply chains. It's huge. Probably the one I'm probably aware of the biggest is the supply of electronic components globally. It is a huge problem. Like we do a lot with robotics and you think that's great, but we now looking at 6 to 9 month delays because we can't get a PLCs any longer. So, you know, what's happened with COVID, it's helped address where these monopolies are maybe in the supply chain. So countries are frantically looking about independent sovereign supply chains now. And like Australia, we lost a lot of that capability. You know, we once upon a time, we had a great iron ore steel industry. We predominantly lost that for the sake of just selling our dirt because, you know, it's still our biggest export commodity is selling iron ore. But what's the value chain to Australia? How's that benefit Australia in the long run? So I suppose when we look at that supply chain, it's actually getting revisited by everyone, and it's making countries and governments re-look at what valuable assets we have. And Australia is in a very unique value proposition here that we have. We have the best resource of renewable energy in wind, solar, and water. And we look at that in its own right. You know, as we move into this a low carbon economy in the future, we can really take advantage of that position. Secondary to that bit, we have huge abundant of natural mineral resources as well too. And we're not very good at sustainable management of those resources. You know, we've got too few cashing in on that. Obviously they're public companies, but at the same time, you know, that it's quite controversial, but they're not really paying taxes in Australia. So even though it's a huge part of the export, they're not really contributing back into Australia other than increasing our GDP. But, you know, so there's a real problem. How do we build those better value chains? How do we identify where the risk is? One thing Australia is built on, you know, is ingenuity, our pioneering spirit. Australians are really good at, you know, solving fundamental problems that the rest of the world can't necessarily do. So we're really good at that, but we haven't turned that into a commercial capability as such. You know, it's sort of locked into, I think, SMEs. One interesting thing with Australia, we're so, you know, they call us down under for a reason. We're so far from the rest of the world, right? And so we don't have access to those larger commercial markets. So as manufacturers, we're very dependent upon local supply chain and local supply of finished products. And this is a real problem. And then add on to that, that around 85% of manufacturing in Australia is SMEs. And out of those SMEs, you know, what defines an SME is that under 20 million a year or under 5 million a year. But the reality is most SMEs are struggling to get their payroll every week to pay their staff. And so because they're limited to that market side. For Australia to really grow our manufacturing capability post-COVID, we've got to look at export. It's the only way we can do it. And to me, what makes the most sense is how do we build value around what we already have? Renewable energy is a big one. the natural resources we have is a big one. We've got to get better at building unique value propositions around those resources. And obviously, we're heavily involved in the space, for instance, sector. And we look at that space sector and we said, okay, every country is rolling out their space program. What can Australia do different? How can Australia's space program be? What's our unique value proposition in that? Okay, we're great from a geospatial positioning for satellites management and things like that. But what do we have that no one else has? And one of those areas is the titanium, but also that innovation as we move forward too. So I think if I focus on that space sector for a minute, if we look at NASA and some of the problems they've got in the US around the space sector, on average, most larger R&D development prototyping projects in space generally overrun by 5 years time-wise. They can overrun by $6 to $8 billion. And so they've changed that program now to look at SMEs. Rather than actually perfecting a process and running over budget over time, they're now more focused on engaging SMEs to get prototypes up there quickly and just make the prototype, and let's review that and get that sorted. And I think Australia can really look at that in a good way. But we also have to figure out where do we have absolute codependency on China in our supply chain. And maybe we've got to revisit that a little bit deeper. We're absolutely too dependent upon that supply chain, and we've got to build some greater local supply chain, the capability as well.
All right. Well, look, we'll certainly be returning to the space topic. It's very much close to both of our hearts, of course. But Steve, I might just ask you about what modern manufacturing techniques, additive manufacturing, for example, but also the Industry 4.0 paradigm offers Australia to remain price competitive in that export future that Jeff so powerfully phrased is our future, and yet we struggle with high labor costs. So how do those new paradigms assist us to be price competitive? Or is maybe that the wrong lens to look at it? Oh, sorry, you're muted, by the way, Steve.
I muted myself because my dog's outside. Fantastic sort of COVID. Welcome to 2021.
Yeah, working from home. Yeah.
And you're muted been the phrase of the year. Anyway, thanks, Alan, and thanks, Jeff. I think that it is a good question. It is a relevant question, actually. Look, I'll put it in the context of Sutton Tools. In some respects, Sutton's has always had to maintain that competitive, as a traditional. I mean, we are that widget manufacturer. Just to highlight some of the things that Jeff started with, we make the widgets, but we don't just churn them out. And I think that's the difference. And there's a word, servitization, which is more and more used to represent this. That we make drills, but we facilitate making holes, or we sell holes. That type of concept. So the capability to make holes. So that's it. So that's where it's very important that we're no longer just selling the tool. We need to supply the know-how on how to use it the best, because many companies make drills, many companies make end mills, but what it is, it's how to get it's the strategy of use, and in machining, it's crucially important to get that strategy right, because that really, even they say that it's the optimization of that particular application, and that's something that is quite tricky to do, and that's what separates a good tool from a very good tool. In that respect, and maybe getting onto advanced manufacturing as well, and 3D printed metal objects. Right now, I think the finish and the surface finish and the tolerances are still something that's going to require some post or tertiary type treatments. And I think there's always going to be a place for metal removal. So I don't think it's going to go away in the terms of the tooling. And then on the terms of advanced manufacturing on the PVD side, there's application there in space and other sort of high-tech areas where you're looking at the tribological contacts between surfaces. But back to that digitalization question you mentioned, and I sort of went off on a bit of a tangent there, I think, with with bringing in some of those threads on advanced manufacturing, is that to be competitive, Sutton's has always had to maintain a particularly low labor rate and high productivity. And that's an automation from, the 60s onwards, essentially, has been something that we've been able to do. So we've been very good in manufacturing are looking at sort of, cellular manufacturing as the sort of the trends have gone in through the 80s and 90s and what have you, So cells, organization of one person looking after 4 or 5 machines, producing parts through that process. But you've also got the issue, and so as a manufacturer, you'd recognize that you're double handling things, that trays of tools, you can replace that with a conveyor belt or a robot or some sort of loader. But now we're starting to see, and that's so manufacturing itself has always had that recognition of productivity has been a goal, but you can see it moving into sort of the back into the office space as well, where for maybe 20 odd years, some people have thought of automation as been Excel and cutting and pasting, and that's automation. And so in that order process, in that order production process, bringing in digitalization tools that might have started off in industry or started off in in the web 2.0 sort of space, they're quite applicable. Mm-hmm. And that's a sort of that's a different view, and that's in that respect it begins you're starting to beginning to sort of get people thinking about digitalization. Now we use the word digitization and digitalization, and we sort of flick them around a bit, but no one's thinking that we're actually taping our CDs. I mean, digitization is maybe easier to say than digitalization, but that's what we're doing, and applying that where we can to sort of make that whole process, not just the productivity on the floor, it's that whole system that you've got as a manufacturer, and trying to make that more competitive. And all those things actually do bring us back to servitization. If you're looking at analysis and data transparency on the floor, that can actually be used for the customer, so a customer can see where their product is. So in your process, and making that process transparent not only helps you make it, but it also has a secondary effect, and that means that this on the service side, your customers can be delighted, I think is a good word to use. You can improve those things all the way through, and it's one of those win-win-win type things, and that's what digitalization and the techniques are doing. And perhaps just to wrap up this sort of comment is that we see like there's a question up about Industry 4 and what have you, but when we sort of see there's a picture that was done in fact, it's done a decade ago, 2011, that Industry 4 steps,
Oh, yeah,
Industry 1, the step up here, complexity coming up on the right-hand side.
Yep.
No way, it's got easier. Maybe the last 20 years, all the computer scientists have worked their bums off to make these systems simpler to use. And it means there's a concept, Gartner has this concept of citizen scientists, or citizen, and that's or the software, citizen software developers, that's something that's really happening. And the tools that were in the 90s, which were ridiculously expensive, are now cheap as chips. And it's really only sort of essentially labor that we have to apply. And even then, with these rapid or low code systems, we can actually cut that down. So I think we're in a great position. Well, one thing, Jeff, I just have to say, I know we don't want to get in the weeds, but I can just reach over and I can pull out this. This is a little USB stick, right? Yeah. It's an XP3. Yeah. 65-week delivery time on this. We're going to get new ones in 2022, somewhere around October. Well, in fact, Christmas next year.
Or it gets better, because with our cyber security protocols, we're not allowed to use USBs anymore.
Oh, okay. Well, actually, luckily I've got an alternative. But yeah, look, that's an interesting one. But this is a wireless device, and it's a ubiquitous. It's a Industry 4 tool. Raspberry Pis. You tried buying a Raspberry Pi, and I was shocked. I've just made some orders, but anyway, that's getting off topic a little bit. But it does maybe highlight that problem about Australia, in the sense that we haven't got that depth of manufacturing. We do rely on the world, and even if we pull back and start to bring manufacturing in onshore, our supply chains are global, and we do rely on that on a global supply chain at the moment. We don't have that depth of manufacturing in Australia to have those things, the Australian version of it. So
certainly I want to maybe return to the sovereign capability and supply chain discussion in a second, but I might just set the scene that within the space context, and as Jeff has already mentioned, this is expected to reach $1 trillion dollar value by 2040. It is growing faster than any one national economy, even pre-COVID. So we have over 100 space-related science and technology companies based here in Victoria. So we have this exciting potential to drive, coordinate the national and international collaboration in space, as well as attract investment. Now, Jeff, on that point, Titomic has been a bit of a leader in this field. So what are the ways that Victorian companies can tap into this broader opportunity? And then we'll talk to the negative and essentially talk about what are the restrictions and what are the requirements we need to have to go further.
Well, I think when we look at space industries, if we look at those 100 companies in Victoria playing in that space sector, they're obviously probably fairly advanced companies already and a bit future thinking in their process. So I think, one of the things that's probably restricting a lot of their opportunity, and a lot of it's around software development too, but one of the things that's really restricting access to capital. I think with anything, when you're building an industry up, capital is what determines your growth rate. We look at historically, things like Silicon Valley, what their success was. The success wasn't just around the innovation. Their success was access to everything from the lawyers, the accountant, and the funding. And Australia, our government doesn't really understand that. We build these like sovereign funds and so forth, but they just sit there and they get over politicized, right? And the money's not going to the right people that are going to build that capability moving forward. Then if I look overseas, I've done a fair bit of work with the UN and other areas around green technology, and even how you define what is green technology. It's a very mythological type of concept of what it actually is. But the amount of investment available to come into Australia is ridiculous amounts. We look at people's superannuation funds and assets on a global thing. And it's, it was pre-COVID, it was about $111 trillion. It seems about quite a few $1 trillion is somehow evaporated. No one knows where it's really gone. But what we do know, there's around $40 trillion that's offset to go towards green and advanced technologies over the next 50 years. Now, within that money, that investment, there is actually a lot of asset funds sitting in bank accounts in Switzerland, sitting in American green bonds. They've got nowhere to put that investment at the moment. Because one of the problems as we're catching up to this low carbon economy that's being pushed from the UN angle, all our alignments in manufacturing moving forward are going to have to meet these particular, and some of them are quite onerous, processes and structures around how investment will come into these sectors. Space sector is obviously a bit of the darling of the investment community at the moment, but Australia's not really attracting that funding. And we have to ask ourselves why. Why are we not seen as a big player in that sector? So for us, the government's trying to doing what they're best they can do, but it comes back to this old saying, you only know what you know. And we have to get better about how do we draw the investment into Australia. And there is no shortage of investment. Like I said, there's trillions of dollars worth of asset funds to be rediversified from oil and gas and other industries to come into green technology. And I can't see a better situation than the space industry that represents some of the, in hindsight, like what we've done previously to where now manufacturing in Australia can go. We've got to start thinking about the future. But we've also got to think about the future around what areas of industry have the most compounded annual growth. And as you mentioned just previously, the amount of growth in that, it's the fastest growing industry in the world is that space industry. But how do we manage that a little bit better? And does anyone know all the answers? No, we don't. But what we have to get better is understanding how do we meet the requirements of investors that want to invest in these sectors? Because this is going to get driven to drive that manufacturing economy in Australia. Has to get supported by investment. There's currently not a disparity, but there's a certain level of unknown quantum with what's required. So we've got to get better and got to get a couple of successes on the board. Like anything, you got to crawl before you walk, and you got to walk before you run. So we're in that crawling phase still in Australia here with our space industry and other industries as well. We've got to get some runs on the board. We've got to showcase to the rest of the world that we can deliver on some items. We can bring revenue on that bit. And people say it's hard to export out of Australia. I don't think it is. If we're not just doing that standard widget and, and actually we're doing something on value to move forward, I think that's great. So I know a little project I was involved with Sutton on tools, for instance, we create some new type of materials using our technologies, not melt-based process. So we get some very interesting properties. And then they get machined those parts. So we did a little project with Sutton where we got them to look at some of their tools. They did pre-characterizations and virtual modeling about those materials and how those tools would cut. So you think of it like a cutting tool, think, oh, what's big about that? Go and buy a drill bit from Bunnings. But the reality is Sutton was able to virtually model that bit and look at improving that part. Like, how do you minimize residual stress? All these particular mechanical properties in machining that part. How do we perfect that process? You take all that way up to the end customer and they say, okay, I can get a part of titanium that's been machined with a Sutton tool and we can minimize the amount of residual stress. We can get maximum output from that machine and improve the output basically on having faster cutting speeds and stuff like that. Who's the benefit of that? Well, the end client's the benefit. So if Australia can actually showcase some of these capabilities, all of a sudden we have an amazing export opportunity that can far exceed some of the stuff done overseas, you know? And I think that's really where we've sort of got to really, I suppose, put our focuses on, is getting some runs on the board. You're not going to get the investment until we can validate that if we receive investment, we can deliver upon that. And come back to these areas, we've got to play more around what our value capability is. What is that unique value proposition in Australia? Renewable energy, resources, and that ingenuity that we have here. They're three key areas. And those areas require quite a broad thing. They require the investment, they require the research and science and STEM support, and they require industry. So those three have to form like a symbiosis to make this successful. And even other countries around the world are failing on this area too. So it comes back to what I call that ecosystem earlier. It's really that focus to move forward. We've got to do that. And I always say, you know, we've got to look at the positives coming out of this COVID thing. We have an opportunity for Australia to reset our economy. We're better than any other country in the world to make advantage of a low carbon economy. So I think it's a great opportunity for Australia, and we've got an amazing period about to unfold for us into the future.
All right, I couldn't agree more about all of that. Steve, did you want to touch on any of that before I asked you the next question, taking us slightly away from this?
Yeah, no, I think it's great points there, Jeff. And look, it's real that you mentioned about cutting tools. We did some work with RMIT, a large piece of work actually. In fact, the researcher who was there was a graduate of RMIT and went through a master's and started a PhD, and then went on to Anchor. But you know, selected laser melting well, he designed the materials sort of and optimized the deposition process for the materials, and then we were able to he created a rod, you know, of the raw material, and then we thought, well, why don't we try making a cutting tool out of it? So we actually did grind and test sort of 3D printed cutting tools, and that's been really interesting. And that was a selective laser melting. That was a technique that was used there. We looked at sort of and titanium deposition, and I can't quite remember the term for the technology, but it's with a bed of powder, and there's a laser moves over that, and the powder bed sort of drops or whatever. And we were able to look at creating taps using that process, and looking at creating sort of quite complex coolant channels in that area. So yeah, that's that. There's some great, like, well, I want to keep sort of pointing out that we do make the widgets, and even making the widgets, you can put a lot of advanced technology into that. And I think there's huge opportunities. Well, opportunities in Australia for companies that are small, that are agile, that are able to do those things, provided, of course, as Jeff pointed out, that you can get the funding, and that they can take that idea forward. So I think, yeah, the skills are here, and I think we'll talk about skills.
Well, actually, I was about to say that was specifically the question I wanted to ask you, Steve, was about in Melbourne. There's top 500 globally ranked unis, and with relevant space-related research disciplines and relationships with international space agencies. And really, the question was, how can Victorian companies benefit from that research collaboration with Swinburne, RMIT? You know, what makes for a successful collaboration to access those skills, as you just said?
Yeah, look, it's very interesting. I mean, Sutton's has worked over many years with universities and has had collaborations, and it's usually boiled down to sort of having some champion or some person who's willing to sort of be that conduit for research within the company and within the university. So it's the potential for university and industry collaboration is huge. I think it can be taken to I don't think SMEs in particular almost know how to take advantage of that, because it's that I think they undervalue they don't realize what they can give to universities in that respect. The huge amount of sort of industrial and business acumen, the knowledge of the processes that they do, and all those things are immense value for universities that don't necessarily have the capabilities of actually, you know, making stuff effectively, or understanding how stuff is made and sold. But on the flip side of that, the industries don't necessarily understand what the universities can give to them. And there's a big disconnect in the sense of the speed at which things happen in industry and happen at universities. I mean, one thing about what Jeff was talking about, I did write it down. I wondered what I'm going to come back and forth, but I want to ask Jeff the time frame. You know, what if the companies in Australia that are successfully beginning that sort of space sort of journey and seeing it as a vehicle. I mean, that's maybe the other thing to come back to while I was saying space, that you don't have to necessarily, a bit like gold, you know, we don't have to be the people digging the gold. We could be the people selling the shovels to the people digging the gold, serving those things. So that's why there's this immense area. We're not all making satellites or rockets, but how long is it? How long a time frame before we see success?
Oh, it's like, well, Titomic, we predominantly work in the aerospace industry, which is probably the worst of the lot, because any new part, any new process is generally an 8-year process from concept to certification. A lot of the work in defense industry can be 8 to 10 years as well. So there's no quick way of doing those industries. I think the space industry, believe it or not, even though it's probably a bit more tech, has a shorter time frame because there's just so much onus to get, as the US, I think Trump said, boots on the moon sort of thing. So, I think that's driving. So I think sometimes we've got to align with areas where the driving is coming from. That said, we look at the aerospace industry. It's about just being very aware of your market. So market research is really doing the analytics. And I think not enough companies really look deeply into the analytics side of it and to form their strategy to move forward. I think the one thing that analytics gives you is understanding your market and understanding where the potential is. So if you look at the aerospace industry or defense, if you're making a new product, it's got to go for a whole series of certification process for a reason. But then if you come a couple of steps back as a tier 1, tier 2, tier 3 supplier, which means you're further down the supply chain, can you improve an existing supply chain? For instance, in all those sectors I've talked about, there's such a huge dependency on China at the moment. And with the whole political tension between the Five Eyes in the West and China, it's opened up a huge opportunity. For instance, if we just look at the titanium, for instance, the titanium industry is completely controlled by Russia and China. And, the space industry would love to use titanium. It's a lightweight, super strong material, but companies such as SpaceX are building stainless steel rockets, which are double the weight of titanium. Why are they doing that? Well, the fundamental reason, they can't access the titanium. They'd have to be dependent upon, Russia for that. Lockheed Martin, one of the biggest defense contractors in the world, who did a lot of validation in the late 50s. Books have been written on it about how they got the supply of titanium. Well, Lockheed's not doing much with titanium anymore because they're co-dependent on that area. But if we look at Australia, we have the largest deposits of mineral sands in the world, but we're selling it as a pigment to go into cosmetics and paint. Why aren't we building a value chain? To give you an idea there, we can sell a ton of that material for about $500 a ton. If we turn that into a metal powder, it's $200,000 a ton. So, you look at the value chain there, but not only selling the powder at $200,000 a ton, if you take it to the next level and build an industry around that 200,000 ton, you get a 10 times, 100 times increase in the value proposition of that material. So I suppose that's when we look at that whole area about implementation and how you deal with some of these more complex industries. Don't look at the bigger picture like, we've got great companies such as Gilmore Space that are built whole rockets, but their focus has been coming on a more cost-effective fuel for their rockets, right? Obviously it's still rocket science to go and build a rocket, right? But their focus has been on that fuel source, which gives them a unique value proposition. And I suppose that's really what it is about addressing those areas about don't get in over your head effectively, right? Find that little market niche. It might be just one small component you're doing or one more small service item that you're adding, and that'll build there. So for us in the space industry at Titomic, we figured out one of the biggest problems with not low satellites, but medium and high one is the radiation shielding. So we have an ability to spray tantalum, and we can put a coating on a satellite in an hour, where previously that would take 6 months doing vapor deposition of micron coatings at a time to build up certain thickness. And that would cost, in the tune of 50,000 upwards. We can now produce that part in a couple of hours for, a few $1,000s. So it's really finding your niches in that market. Are we going to produce whole satellites? No, we're not. But we can provide a coating technology for those satellites. So I think it's really, like I said, do the analytics, understand what your strategy go-to-market is, and then chase that very hard.
I couldn't agree more. Now, one challenge with all of this, of course, is the pipeline and the development of young undergrads, researchers, and getting them into the sector. And Victoria is the education state. We're particularly so in STEM. So I was wondering, how does that next generation of young researchers and STEM students go into a career in the Australian space sector? And just as a point on that, Jeff, I was struck when I visited Titomic in the before COVID periods, when there was just the sheer number of our Swinburne interns were there. It was extraordinary. So, what is the role in building up that pipeline between the university and the industry and even government? Is it an all ecosystem kind of approach to build up those career paths?
Yeah, well, look, I've got probably 30 plus years experience dealing with universities and researchers, and I haven't always seen eye to eye. For instance, I think Steve touched on a point earlier. If we look at developing a solution to a problem from an industry perspective, 6 months is a long time. Where a PhD will look at 2.5 to 3 years on that same problem, and that still to this day really frustrates me. So I'm trying to work with the university to understand that bit. So we're taking on some analogy from the software industry, what we call the sprints. So if I have a PhD student working on a particular project or a master's, we'll do sprints. So we said we want, even though there's a hypothesis being done by that PhD, we want a commercial outtake every 6 months out of their PhD. So it's really about collaborating together, understanding what is industry wanting out of it, what are our needs, and what's the need of the university. But more importantly, this is all focused around the career of that person, right? So you don't want to do, obviously there's always the need for fundamental science, but I'm a big exponent about, how many people nowadays want to make a career out of fundamental science. It's not that much. They want to see any validation they're doing on a hypothesis and a PhD, they want to see it used. They want to create a legacy around expertise in that sector. So we work very closely, for instance, with Swinburne. I think right at the moment we have 2 full-time PhDs, another 3 that have been delayed a little bit because of the COVID. But they're really focused on deliverables we've got in the near future. So we have to be quite strategized in how we do that. But we did the analytics, understand we know this industry is going to go to this sector. We need to now start to look at how do we manage that resource for us moving forward as a company. And that resource has to come from the next generation of students. So, and I think companies don't look at that too deeply. There's a general saying within most of the advanced manufacturing industries, or let's call it more your defense aerospace, that if we get a graduate in, it takes generally 6 months to train that person up to even a level where you can pretty much leave them by themselves. And in that 6 month period, it's requiring another staff member to train that person. So all of a sudden you lost that capability. So this is where a lot more planning needs to be done by industry, and probably why in Australia, most students in STEM gravitate towards the big multinationals. And so we're not getting those students, they're not going towards the SMEs. And there's a couple of reasons for that. They see it as not sexy, and also for their own career development, having a big multinational as your first place of in your career as a job is helpful then to move forward. But at the same time, we look at if we change the cultural thinking within small organisation manufacturing in Australia, you can make an amazing career in an SME if you're the domain expert in that company on a particular sector. And this is a real problem that industry faces when we have a particular domain expert. If something happened to that person, they get run over by a bus tomorrow, does that leave a huge resource drain on that company? Yes, it does. So it's a big question that no one's actually resolved the situation here, but where are we going to get the future resource of human skills to do this? So this is why I've seen a fundamental change over the last 10 years in how industry collaborate with universities. Previously, most universities, or even your bigger research institutes such as your DSTG, your CSRO, these ones, wouldn't want to touch an SME. But nowadays, that's become a lot more their bread and butter to work with the smaller companies. So I think things are changing, and I think come back to what I said earlier. Do we know all the answers? No, we don't. But purely on the fact that that symbiosis is there now between research, universities, and industry, it can only get better. And what will drive industry on that is success stories, right? The more they hear about a success story, the more it drives that capability. Will an average SME want to engage at PhD? Probably not. But if that PhD can solve a fundamental problem that's going to bring revenue for him in the door, then it's worth making that investment. And so I think that's where I look at it. It's not a perfect situation, but it's definitely better than what it previously was. I think COVID's put a bit more spotlight on that drain that we had from COVID around the students. We had so many international students at the sacrifice of building our own capability with the Australian generation moving forward. Our economic growth in Australia pre-COVID was dependent upon, population growth and international people coming into this country. Or why? That was nearly like we're playing in a little comfort zone, taking the easy option there. We've got to be smarter on how we do this. So I think the analogy is like, how do we engage the younger generation? That's happening now in the primary and secondary schools. But we've got to align also from that next generation of education, so they're getting them ready for the workforce, not creating a problem for the workforce.
I think at Swinburne, one of our moonshots is to actually have industry experience internships at whatever the exact format that benefits the company and the student, but ensure that every student has that opportunity to exactly get that kind of experience. But Steve, I might leave you with the last words on this before I throw to our audience. So for the audience, please raise your digital hand, and then we'll turn on your cameras and you can ask your specific question. But Steve, on this point of in discussion.
Yeah, look, it's a really important point. I think Jeff hit the nail on the head there. But the other thing, the future's intern-shaped. I mean, that you can sort of say that, really. But work integrated learning and the associate degree level, they are sort of things that are coming in, because Jeff's right. Not everybody needs a PhD student, and often the problems that small companies have aren't that tricky. They just need someone to actually just focus on it. The hard part is that the companies, that what students lack, as Jeff highlighted, is that company knowledge, and you can't leave them on their own necessarily. So they have to gain that, and there's no real shortcut to it. So the problem being that if you just got one-on-one, and the company invests a lot of time in that person, and then they're not there for that long a time and they leave, that's not so good. But if you can keep them, I think that's important. But that work integrated learning and the associate degree things that are starting to come now are sort of the modern equivalent of essentially apprenticeships, because apprentices or apprenticeships would be where people learnt craft. And I think we've lost that a bit at universities. And in fact, even workshop practices as an engineer, they don't get that. It's quite expensive to do. And so we've optimized the courses to such a degree that we've not left enough slack for those other learnings that are actually important for industry. So I could talk about this for a very long time, but I think Jeff was very eloquent in those points. So back to you, Alan. And I'm conscious of the time.
All right. Well, look, again, just a reminder to the attendees, if you could put your digital hand up, and then we'll be able to turn on your camera so that you can actually ask the question yourself if you like. We also have a lot of questions in the chat. So Amit, oh no, Reese Jones has put his hand up. So Reese, take it away. We'll just slowly press buttons in the background.
Okay. Can you hear me?
Yes.
Can you hear me? I have a comment. The comment is this. If we are going to be producing something that is world competitive, there is no point in having undergraduate students involved in anything. What you need is somebody who has had an established capability and is world recognized for competing in the field that the company is interested in. Because if it's a simple idea, you've got simple students around the world, and they can all solve these simple students, and you don't have a competitive edge. You really need world-leading figures. Now, the problem that you have is that the universities have changed their employment processes, recruitment processes. And in today's COVID thing, it's even more difficult. But the number of people who are capable of thinking outside the box, and it's the outside the box people thoughts that you need to be competitive, are very, very small. And the universities tend to appoint people who can win ARC discovery grants. And that's not what is necessarily needed. It is a hugely different thing to be able to write a paper that will appear in a journal that nobody ever uses in the future. And most people do that.
Reese,
So
I might jump in and just ask,
I think I've said what I need, so I can shut up.
All right, thank you. Well, I might just reformulate part of the question that I was hearing there as well, and I think it's a fantastically important point, and that is, how do we have established workforce either retrain, retranslate, essentially move across and use their experience and gain that opportunity within companies, leaving aside the challenge of the ARC, which we don't have time. I could talk.
No. That's not the question. That's not the question.
Okay, Reese, yeah. I think I can sort of get to what you're getting at. If you, well, I went to the launch of the Future Manufacturing, or whatever it was called, at Swinburne, and the speaker there was the chief scientist at the time. Is it Alan Finkel? I think it was very tall.
It was Alan Finkel at the time.
Yeah. And he made a really good point. He said, look, Steve Jobs, whatever it is, Microsoft guy, they didn't learn, they didn't do computing at university. They learned maths and physics, and they had the communication skills and English. So he said if he had to teach anything at school, it would be maths, physics, and English. So we're back to sort of STEM skills now. Of course, the arts come into that as well. It's very important. But the point he was trying to make is that we can't predict the future. We can't say if we all these jobs change in 5 years, etc., etc. But the reality is, if we give students a rich basic level of practice, or whatever you want to call it, but give them the confidence that they can solve problems. So understand that they have to identify problems, because the problem might not be visible to many people in companies, and that's the other issue with small companies, is they don't know they've got a problem. So someone has to come in and identify a problem. Then they have to create a solution to a problem that no one's seen before, and then they have to solve it, and then they have to work out whether they've solved it properly. So those sort of skill sets are very, very important, and I think if we can develop those, it becomes less of an issue that of training the expert, because we don't know what that expertise is going to be. We just need to give them a well-rounded capability of problem solving, of being able to have the confidence to do that, and to tackle issues and to define things. So I think it's much more. Oh, well, thank you, Patrick. Patrick's Googled it, and of course, Bill Gates did study computer science. But I'm sure you can find many examples where when those fields weren't there, where people just took the basic learnings, physics and chemistry and maths, to develop then the new industries on top of that. So I don't know. We're not going to fix everything at Reese. I know that, but
yeah. Jeff, I might just to have your thoughts on particularly an older workforce and bringing in people with experience, actual significant experience. It can sometimes be a challenge through career interruptions, or even just moving into the space domain, for example, as a translation of existing capabilities. Is that an insurmountable challenge?
No, look, it's something actually close to my heart that I've worked on for around about 10 years, trying to solve that problem. And I think when Titomic first started, I brought in a lot of quite sort of senior metallurgists and other people that had a lot of experience in the metals industry. And the idea was I was going to bring in people at the end of their career to then oversee younger people. The problem is that there was a level of tension and toxicity so great, it didn't work. Now, I could not predict that. But that's what we've actually found. What situation I have now, I have a lot of young staff that work for the company and not many more senior ones, right? And the reason for that, there was just such a wide disparity between those two groups, right? And I suppose some of that, we fall in this problem sometimes with older people. We get comfortable in our process and we don't want to think outside the square. It's an inherent problem probably in the defense industry more than anything else. This is the way we've always done it, so we're not going to change the thinking. But on the other level, if you look at that intern program we're doing at Titomic, for instance, where Max Osborne, our head of engineering there, he's come from Boeing, 15 years experience there. He's quite good with those younger people. But we give them a real-time problem. So, for instance, we've got a project we're giving the interns at the moment. It's a real problem we have on a material. And we've said, okay, go away. You come back with some solutions to that problem, right? It's not costing our company greatly as far as that sponsorship we do on those interns, but they're going to give us a new way of thinking, a younger creative concept on how we solve those problems. Then we can go back to, more, some of the professors we work with, like I work closely with Professor Reese Jones. And so really, when you have that balance between the two things, young out of the box thinking from the younger generation, but then also making sure that's aligned with your most prominent people in industry that actually understand the benchmarks, understand the reason. Like, because you won't get along young people sometimes go, I'll just do it this way. And we go, we can't. The particular benchmark certification is why we do that. So I think once you identify the problems, that's easy to come up with a solution. But too often, we don't go deep enough into understanding the analytics of a problem, the root cause of a problem, to come up with a proper solution. And this, I suppose, where the older generation has that skill set, understanding a root cause of a problem. We can't expect younger generation to see that. What we can expect the younger generation to do is give them that root cause problem and go, what's the out of the box thinking to solve this problem? So I think it's starting to happen. We tried 10 years ago and probably too premature, and I've seen it definitely grow. So now I think that it took us a while to understand that fit. The fit to me is not using senior industry-based people, but senior research fellows and professors and so forth to align with those younger people. And I think that's where the balance is, because I think there's just too much disparity between some of the older industry people that are locked in process will never change. It's that dinosaur Luddite type of thinking. And we don't want that. That's not going to help any company. As far as the older staff in a company, we constantly do mapping of actually the progression. So we're constantly pushing to do upgraded training. How do we help the older generation get better at what they do, stay modernized in what they do? So the company will support them. We actually offer to pay for courses to be done to update their skill sets as well. So, like, once again, I think that's the solution that's working for Titomic. Does it work for everyone? I'm not really sure, but we have put a lot of effort into trying to determine this problem and find a resolution to it.
All right, wonderful stuff. Thomas Patterson, if we can turn your mic on.
Hi, everyone. Can you hear me okay?
Yes.
Great. Thanks a lot for the panel discussion. My question was surrounding the challenges of raising capital in Australia. I think Jeff talked about how, trying to get some money to fund your idea is quite challenging. I'm a postdoc here at SEAM, but before I joined, I spent some time in Silicon Valley, and I sort of recognize what you're saying, that there's quite a big difference in the Australian ecosystem compared to one in the Valley, where a lot of people take chances. There's a lot of money floating around. There's a lot of good ideas that come out, and a lot of technologies out of universities and other places get spun into a company. Do you have any opinion on where maybe the majority of heavy lifting needs to occur in Australia in order to sort of become an ecosystem like that? I know the biomedical field, particularly in Melbourne, is sort of moving, but I would say in terms of manufacturing, apart from biomedical devices, maybe it's a little bit slower.
Yeah, so I think you hit a very good point. The problem with Australian investment is we don't have patient investment capital in Australia. That's really what comes down to more than anything else. Any investor in Australia, they're investing because they've already got a bit of surplus cash, but they want immediate return on the investment, And I always say the problem with investment in Australia is you may as well go to the casino and put all your chips on red or black, right? Because that's really what it's about. Silicon Valley is built on that 1 in 4 principle, where 1 in 4 companies will be successful, and the other 3 they can write off that investment, because the one successful makes so much gain it covers the loss in the other areas. But the real problem we've got in Australia, even when we look at some of the sovereign wealth funds, believe it or not, have not invested a single dollar in any 3D printing company in Australia, but they took quite a big investment in Desktop Metals in the US. How that's even allowed to happen really frustrates me. And then on the other level, relative to that bit too, is how do we access, like in the US, there's these things called SPACs and investment, and there's huge interest in investment into Australia, the US, but there's these onerous tax rulings that doesn't allow a lot of US companies or investment to invest in Australia. Our government's got to get a lot better at opening up that opportunity. There is a huge amount of investment opportunity to come into Australia, And I'm trying to work on that to open up that opportunity. But there are some good companies. For instance, Joe Hocking, the ex-treasurer and ambassador in the US, he has a new company called Bondi Partners. Now, Bondi Partners is doing a lot of work trying to bring in green bonds and other investment into Australia. So it is starting to happen, but we're really just got to move away from that, investment into blue chip companies and really that risk. Australian super funds is a big one. Our asset funds in Australia do not get invested locally, but they're investing in that 1 in 4 principle in overseas, but not in Australia. The only investment they'll make in Australia is, companies already running, such as Afterpay and companies such as that. So, we're not good at supporting our own growth, and we've got to get better at that. There's too much disparity between that investment industry, investment banks in Australia, the banking industry. We're not supporting local industry, and that needs to change.
I couldn't agree more. Steve, I wonder if you wanted to comment about the aspects of Reese raised the ARC spectre and the role that ARC funding perhaps plays, or government funding more generally, in addition to this VC discussion we've just been having. What place has the ARC and government funding to support this level of work?
Look, it's hard for me to comment on the ARC side. I think the areas where, for example, with Sutton's that they've benefited from have been in the CRC, in the CRCs. So there's cooperative research centres. Now, of course, the ARCs we have, Sutton has been involved in the past, and that's tended to be where, well, I suppose it's that concept of which drives which. Is it industry driven or is it academic sort of driven? And I think although the ARCs we've been involved with had that industry flavour, it was often sort of couched in an academic sort of background, and the areas that are problematic are essentially around about results, and Jeff touched on it before about those longer term sort of PhD sort of activities that companies are outcomes driven. So I think that the CRC sort of model of cooperative research works very well when companies engage and universities engage, because it does cover those things that Jeff raised about the requirements for outcomes. And so there's a customer there essentially, and the customer has a set of requirements. So as long as those and the group, the CRC is usually a bigger organization. It's not sort of one to one. There's a group of universities plus a group of companies, and so that mix is quite nice. And Sutton's has been involved in the Defence Materials Technology Centre, which has a CRC model behind it as well, and that's been a very long term actually activity. We started at Sutton's in 2008, I think it sort of kicked off, and so that's gone on for some time, and it's allowed us to look at sort of next generation cutting tools, an activity through with Swinburne now as well, and plus an activity with Seam. So it's what's been successful there has been where we've been able to align the research outcomes with the outcomes, with the commercial outcomes. And when those have been aligned, it's worked. And that can be long term. PhDs have gone through that, and that alignment, that underlying sort of thread that takes years to do, provided we get smaller outcomes that we can actually apply in manufacturing, has been really, really beneficial. So that's I think covers really what I want to sort of say on that point. I've got, sorry everybody, I'm bipping away. Another meeting.
So look, we have basically a few more minutes if anyone wanted to ask their last burning question, but I was going to maybe ask you to gaze into your crystal ball and make the prediction for what the space sector, since this is a special topic, the space sector here in Victoria will look like 10 years from now, and really, if there is a range of possibilities there, what are the practical steps that we as an ecosystem, industry, academia, and government can do to make the better of those potential possibilities come to bear? So without any warning on that question, Jeff.
Look, I'll have to play in the Titomic strength here, which is metal manufacturing using additive manufacturing. I think that's a huge capability. And like I said, we have an opportunity to build a whole value chain around titanium in Australia and be the global leader in space vehicles produced with titanium. No one will be able to touch our capability because we can go from mining the mineral, processing it, producing parts, using all the advanced manufacturing capabilities around that sector. So I think that's a huge capability to us to move in the future, and it's a growth sector as well. So I think that's our focus at Titomic, and what I'm a big exponent in pushing that capability as well.
Steve.
Well, look, it's an interesting one, isn't it? In some respects, it sounds, for Sutton Tools, because it's a manufacturer, it seems like completely sort of something that Sutton's would be on the periphery of. But that's where you get back to supply chains. We, as a cutting tool manufacturer and as a service provider for PVD coatings, our customers are extraordinarily varied, and there's things that we put coatings on that are very surprising, from dental implants to motorcycle forks to can manufacturing, forming tools and punches and components. I mean, we've done some components that end up in some fairly esoteric sort of situations. So I think that's an interesting one, and so that's essentially where I think Sutton's and companies like Sutton's in that service side can actually benefit from these sort of initiatives where there's a focus, there's a goal, there's an aim of space. It's sexy, it's great. It's everyone wants to. Well, I don't know. I'm here with my grey beard, wanting to be, I remember looking back and having my wallpaper when I was little was Apollo, was all the modules and spacemen. So sure. wanting to get there was something that was really important, I think, for kids of the 60s and 70s.
Jeff, do you want to?
Can I just touch on something there too? So even though we talk about this additive manufacturing and greening the process to build titanium space components, one thing that's always going to require is still some final machining post processing as well too. So Australia after the Second World War had the biggest sheet metal capability in the world. I think in the late 80s, early 90s, we had the highest uptake of laser cutting machines in the world per capita anywhere. We have a great history as far as metal manufacturing in Victoria, and we need to get back there again. And obviously companies like Titomic and even Sutton will be using tooling for the next 50 years. We'll need cutters. So it's not a dying industry. I think it's, like I said, where we have future industry, advanced technology, advanced additive manufacturing capability. It's still going to require some traditional manufacturing capability to go hand in hand.
Here, not even the sky is the limit when we're planning on reaching the moon as part of NASA Artemis, for example. So we've had some incredible recent announcements in government grants, MMI schemes to support space. Stay tuned for some very exciting news that's coming out soon regarding those grants. But really, it's an exciting time, and I think the ongoing government direction and support and industry collaborating very closely with university will see us reach that exciting future you've outlined both. So thank you, Jeff and Steve, for your time today. And I want to acknowledge the support in making today possible of SEAM, the Australian Research Council Industrial Transformation Training Centre in Surface Engineering for Advanced Materials. Who would have guessed they use an acronym as a preference? So SEAM is Australia's premier manufacturing R&D centre focused on applied research with tangible outcomes to nurture and cultivate the industrial innovation leaders of tomorrow. And I think we've done just that in today's conversation. So thank you all. Please go to the SEAM website, arcseam.com.au, to learn more about this topic and our guests and their company's work. Stay safe all, and thank you for joining us.
Thank you.